So here is the structure of what is called a system in systemic approach. It's a quite simple model. A system is defined with a box, okay, and you can see the contour of the box, and it's called the envelope or the wall of the box. Inside the box you have an internal activity or a process. You have many elements in this box which interact with each other. And you have what is very important, you have flows, incoming flows and outcoming flows or interactions between this system, between the box and the outside world. So that's the essential structure of a system. Yeah? So when we do modelization, we define what are the border, the envelope of the system. So we have to be clear what is inside the system, and what are the interactions between the system and the external world through the interface, through the envelope. A very useful, let's say, technique of modelization is to consider that a system is made of subsystems. So this modelization we did in the previous slide, showing that we have this envelope and flow, we can decompose this system and show that inside the system we have the same structure which appear again, and which are subsystems, which are subsystems which communicate between themselves through the same structure, an envelope and flow in, flow out. So it's called a decomposition of the system in subsystem. So for example, if you see define a forest, you can imagine that a tree is a subsystem, another tree is another subsystem of the global system, which is the forest, and one tree will exchange maybe through mycelium some compounds with another tree or with another subsystem, which is, I don't know, a bird. A bird could be defined as a subsystem, and the bird is interacting with the tree in different matters. So that's a very powerful tool for analyzing the system and being able to dig into, to concentrate the attention into subsystems. Here is the, let's say, visualization of this concept of decomposition. You can see that this subsystem has exactly the structure of a system. So just is a subsystem inside a system. And this system is a subsystem inside a more global system. This is a practical instantiation of the model, where you see here a subsystem is a chicken. Here is the farmer, which is a subsystem as well. And the interaction is maybe one of them, is that the farmer gets the eggs of the chicken. And so there is a flow from the chicken to the farmer, and this flow is eggs. The subsystem chicken will interact with insect, will eat the insect, will control the insect. The insect will eat the grass, and as well the chicken can eat the grass, etc., etc. So you can imagine that in a natural ecosystem, the number of interactions between the elements is really huge, and this is an easy way to modelize this structure and these interactions.